Hey you guys!
What's up guys? Today we're going to learn about how to do the empirical formula of a compound.
So keep on watching.
What is an empirical formula? Well, the formula is the smallest mole-to-mole ratio. Got it? Got it. So for today's question, it's going to be a certain unknown compound consists of carbon, hydrogen, and nitrogen. Combustion of 1.250 grams of this compound produces 2.555 grams of CO2 and 1.307 grams of H2O. What is the empirical formula of this compound? Because this process of combustion, it would react with oxygen to produce carbon dioxide and water. This chemical reaction is dealing with carbon, hydrogen, and nitrogen. Our products would be carbon, hydrogen, and nitrogen.
So since this problem actually gives us the amount of grams in certain compounds, we're going to go ahead and write down what we know.
So we do know that there is 1.250 grams of the unknown compound, 2.555 grams of carbon dioxide, and 1.307 grams of water. So we're just going to go ahead and write that to kind of help our thoughts out.
So next, we're going to find the moles of carbon, since that is the first part of the unknown compound. So first we're going to use what they give us. So they give us the grams of carbon dioxide, which is 2.555 grams. So we're going to write that first, and then we're going to convert using molar mass. So we're going to find the molar mass of carbon dioxide, which is 44.008 grams. And then we're going to use 1 mole of carbon dioxide to convert. And then after that, we're going to do the mole-to-mole ratio, carbon dioxide to carbon. And then once we input that all into the calculator, we should get 0.058 moles of carbon.
So next in the problem, we're going to find the moles of hydrogen. Since they did give us the grams of H2O, we're going to use that. So we're going to write first 1.307 grams of H2O since it does have hydrogen. And then we're going to convert using molar mass. So find the molar mass of water, which is 18.019 grams of water. And then we're just going to write 1 mole of water to convert. So next we're going to use a mole-to-mole ratio. So the mole-to-mole ratio is 1 mole. Water is 2 moles of hydrogen. So once we input that into the calculator, we should get 0.145 moles of hydrogen. The reason why we decided to use 2 moles of hydrogen over 1 mole of H2O is because this is the mole-to-mole ratio, and we're looking for the moles of hydrogen. And in this case, there's 2 hydrogens in this mole-to-mole ratio.
Because we found the moles of carbon and moles of hydrogen, what's left to find is the moles of nitrogen. But because we can't really do that because we don't know what the unknown compound is, but we know the total mass of the unknown compound, we can take 1.250 grams, subtract it from the moles of carbon, times the atomic mass of it, minus the moles of hydrogen times the atomic mass of that. And we should have found grams of nitrogen. Because we found the grams of nitrogen, we can now find the moles of nitrogen. In order to do this, we're going to take the grams of nitrogen, times it by the molar mass of nitrogen.
After we entered this in the calculator, we found the moles of nitrogen.
Okay, so now that we have calculated out the moles of carbon, hydrogen, and nitrogen, we can now find the ratios of the unknown compound. So first we're going to find the smallest number of moles, which is actually the nitrogen at 0.029. It's the smallest number out of all 3 of them. So we're going to divide that smallest number by all 3 moles.
So, for example, for carbon, we're going to get the mole for carbon and divide it by the smallest mole ratio, which is for nitrogen. So it's going to be 0.058 divided by 0.029 since it is the smallest one. And then we're just going to repeat that for hydrogen and nitrogen as well. So hydrogen is going to be 0.145 divided by 0.029. And then for nitrogen, 0.029 divided by 0.029. So once we divide those into the calculator, we're going to get 2 for carbon, 5 for hydrogen, and 1 for nitrogen. So those numbers will give you your ratio. So now we have calculated out the unknown compound's empirical formula. And that's how you calculate empirical formula. Hope this video helped you.